Hello, welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We're a meetup group, teach people how to use Python and sometimes get into machine learning stuff. I'm mainly looking at the Python stuff. And today we're going to look at how to use Python to get data through an API. And the API we're going to use is Strava. So this is going to help if you've got your own Strava account, but if not, you can just watch along and then maybe later create a Strava account and try the things out. Now I've created a notebook, a Jupyter notebook running on Google Colab, so you can follow along and do all the steps. So it's a live session, and the advantage of live sessions is that you can ask questions. So I will be watching for questions on Slack, and there's instructions on joining Slack. So I'm in Learning to Code, so the instructions are down below in the description of the video, and also on YouTube, on Meetup if you've registered on Meetup. But I'll also watch the YouTube chat. There's just the chat section I pulled out, so I don't get the infinite mirroring of the video I'm currently showing. And yeah, just put your questions in there, and hopefully I can answer them as we're going through. So there's a few things that can go wrong in this, so yeah, don't be afraid to ask questions as we go. So the first thing we'll do is we'll open up the Google Colab notebook, and I've got the link just here, so we'll open that in a new tab. So Jupyter notebooks are just a series of cells that run little Python scripts. A fantastic way to learn, and actually a really convenient way of running Python if you're doing data science. But we're going to use it today. Some parts of it work quite well, other parts not quite, but I'll show you how to get around them. So the first thing I'd recommend, see it says here changes will not be saved, and that's because you've got you're currently looking at my notebook. So if we say copy to drive, you'll get a copy that'll go into your Google Drive, and then you'll be able to make changes, save outputs if you want, and yep, come back to it later. All right, so these it's got I've turned off all the outputs, so that's fine. I'll close that. These notebooks, just a series of cells being text cells, like this formatted text cell describing what we're going to do today, and then lower down we have some Python cells that just look slightly different, and there you can run the Python code. So we're going to use Python's request library to communicate with the REST API. We're going to use an access token, and then we're going to show how to refresh an access token. That's one of the hardest things. It's not so hard to do, it's just hard to debug what's going wrong when it doesn't work. And then we're going to collect some user data, and then we're going to create a Strava token with a larger scope, which means we can do more than just get a user's data. We can get information about their activities as well, and then we'll do that. We'll collect some activity data, and we'll show how to plot that activity data on a map. And it's really just a tip of the iceberg doing this sort of stuff. There's a whole lot more that you can do with the Strava data. So we've got some links here. There's the meetup event, the YouTube of course, which you're watching, and the notebook. And we've also got on GitHub, and GitHub I put a copy of all of these, including the links, so you can look through all the old links of past meetups that I've done. And this one I've actually converted into a Python script where I've stored it in GitHub, and so it doesn't it's not a notebook, so you could try running it from the command line or from a IDE such as VS Code or PyCharm, if you want to run your Python scripts that way. So I'll give you a couple of references here. That's strava.com, that's where you can create one. I've just linked one, signed up using my Google account to get in there, and developers.strava.com will give you information about how to use the API. So the API means Application Programming Interface, and it's a way for programs to talk to each other. So we've got our program here. It's wanting to get data from Strava's program, so they talk using a language, and it's going to be the REST API that they're going to do. They're going to use. So the REST means that we're going to be doing it just using the standard protocols that the web uses for people browsing the web, and we'll be using the JSON format for collecting data, because that's the only one that Strava provide, and JSON is JavaScript object notation. So I'll show you how to use that and get the data out of that. All right, and it's also authentication is a big part of using these APIs, so we'll have a look at how that works as well. So the first thing you need to do, if you want to do this, is you have to create your own API key. So I can't show you mine, but it's easy enough to create one for yourself. And so the way you do that is you go to this link here, strava.com settings/API. Now I've gone to that link and I've logged in, but my Google user I use for this YouTube and this Colab is different to the user I've got for Strava. So let's go to the Strava, and here I am. I've logged into my Google account that is connected, that allows me to log into Strava. I've logged into Strava and I've gone to this URL here, which is what I had on the notebook, and it will take you straight to this place here, my API application. Now I set this up a while ago, so I can't remember what you'll see if you haven't created it. It may have one there automatically, but I suspect you have a new button that you have to create a new one. So do that, and you'll probably have to fill in this data here. So the application name is not really important, it's just for you to know which application it is. So you can call it BPAML if you want, which is Beginners Python and Machine Learning. We just say we're a data importer. We're just trying to import some data from Strava. We're not a member of any club. Website, just put any website there. It doesn't really matter. You can use that one if you want. Doesn't matter. That's just one I've got that I was using for registrations. And a bit of a description. I've just typed in teaching Python programming using an API such as Strava's. And then you've got the callback domain. Now, our callbacks will be going to localhost, and you can put localhost in there. If you want to use their Swagger environment for testing the APIs, you can also put this callback domain in there, developers.strava.com. And I tried it. If I put in developers.strava.com and I do callbacks to localhost, it still works. So that's probably the best thing to do, is just put in developers.strava.com, and then you can use the Swagger if you want. Okay, once you've done that, you'll get this API key, and it's all very secret. So if I could click on the show, but I'm not allowed to, I show you what my secret looks like, what my access token looks like, and the refresh token. The scope is read, allows me, which means it's allowing me to read just some of the data about the owner of this key. And that's all it's saying about that. So try that, and once you've created that API key, then we'll flip back to our notebook and start running. So we've created that, and there are the instructions. Okay, so I'm going to click connect up here, and Google Colab is going to set up a virtual private server for me to run all this stuff. I'm very excited because Colab now gives the free users this terminal button down the bottom left, which if you want to run terminal commands on your VPS. So that's now available for free. Okay, and we need to run these cells. So the first one we run is just importing the libraries that we want. So importing pathlib, pprint, datetime, JSON, sys and zone info. So they're all standard libraries in the Python ecosystem. And then there's this other one, requests, and that's a third-party library, but it's such a good one that even the Python documentation recommends that we use that when doing HTTP requests. You can see that Colab's running Python version 3.12. That's what sys.version tells us. So that's quite a recent version, so that's all good. Now what I like to do is store my API keys in my Google Drive. And if I look here, so you see I clicked on the folder icon on the left, it shows me the files that I've got access to when I'm running this notebook. And every time I start a new notebook or come back to a notebook I've been using before, any files that were there have been deleted, and I just get my sample data and nothing else. So I like to link my Google Drive to this account as well, and you can do that by these two lines of code from Google.Colab, import drive, and drive.mount/content/drive. So I'll just run that, and this is asking us to connect, so I'll click on I want to connect, and it goes through the authentication, and I say that's what I want to do because I've all logged in, so it's fine. Google Drive wants access, and I'm happy for it to have access, so I can continue. And by doing this, it means that I can store my API keys in a secure place, and I can see my old notebooks, and I've got my API keys. I can even put my Kaggle key. These days I probably put them in the same folder, and it means it's all ready. So next time I come, I don't have to store my API keys in Google Colab. I can just store them in my Google Drive, and it will all run fine. So let's run a bit of code to see how we can create a file in our folder. Now I've got one here from before, so I'm just going to delete that file, JSON demo, and here's the code. So we're going to put all that information from the Strava API, most of which was the secret, and put it into a dictionary. So this is how you create a dictionary in Python. You open it up with curly braces, and then you have a series of keys and value pairs. Each key and value is separated by a colon, and each pair is separated by a comma. And so first of all, we'll just start with this data and see what it looks like. So if I run this, it's going to create this dictionary. Then it's going to look at the path, and it's going to look for drive/my drive, and you have to use forward slashes here, even if you're on a Windows computer, because the Google Colab is running on a Linux computer, and they use forward slashes for the path, and even Python prefers forward slashes. So even if you are on Windows, I think you use forward slashes for Windows in your Python programs, and that way it's consistent everywhere. My drive, so we can see the path here, drive/my drive/API keys /JSON demo, and we're using the path library from Python to store that as an object into our variable called file path. Then we want to make sure that all those directories actually exist. In case they don't, we run this here, make directory of the parent of the file that we want, and all the parents of that parent we also want to make. If they don't already exist, that's okay. We don't want it to throw an error. So now we've created the directories, we can create the file. And I've just used these two lines of code here. With the file, we open it for writing as a JSON file. and that's the name of the object, and it's all in this. By using the with statement, it means when we've finished with it, it will actually automatically close the file for us, so we don't have to worry about resources. That's a good thing to do with files. So we now use our JSON library to dump our dictionary in JSON format into the file. And I'll put some indentation equals 2 just so it looks a bit pretty. And then I'm going to open it back out and read the data back out into a new variable, dummy API key, and then I'm going to pretty print it. So when I run that, this is what I get back. You see the output here. And so if you run that, you should get the same thing, especially if you've connected to your Google Drive, and you should now have an API keys folder in your Google Drive. And if I go to this file, if I double click on it, it opens up here in Colab, and I can see the contents. So that's what the JSON looks like, and this is what a dictionary looks like. So they're pretty similar. The really only difference there is they're using double quotes, and the dictionary is getting displayed with single quotes. But I think you can use either in JSON, and you can certainly use either in Python. Alright, so this is the first task for you. Try to do that now to create a file called Strava key.json with your actual client ID, client secret, my secret, and refresh token. You can just use the same expires as before, which will just give you the current timestamp. Okay, so I'm going to help along. So what you're going to do is you're going to copy and paste this from here. Put the code in here. Then you're going to change the name of the file here to strava-key.json. I'm just going to give it a different name so I don't wipe out my actual key. I'll call it Strava key demo. And then you're going to go back over to your Strava API page and copy these things one at a time. So each one you have to press show and then copy and paste. So you grab it like that, come back to Colab and paste it in. Let's try paste. There we go. No, I'm not going to show you my secrets, but if we run that, you can see that it's come up with now it's got my ID. So do all that, and you can see over here on the left that it's created the file. So I'll just give you a minute to do that. All right, so that's assuming you've got that all done. Now, and you can now see your secrets and tokens here showing up. But of course, you're not broadcasting, so that's okay. Now, I've written a function here so that I can show you part of what my file looks like without showing the whole thing. So you can try this with your file as well. So we define the function, we'll just run that cell, and now that function is defined, didn't actually do anything because we only defined it there. And then we call it here. I say partially reveal the API key, which is a dictionary that I've loaded from my actual Strava key.json. So if we do that, and it's just showing the first half of all the characters and the full length, 40, 40, 40, and there's my expires at time. Okay, now one of the problems I was having when I was doing this is that every time I'd come back to work on it, my token had expired and wasn't sure what to do, how to refresh it. So once I've worked out how to do that, I thought the first thing we should do is refresh our our key. So I've defined this function here, refresh key, that you pass in your current key, and it will, if it hasn't expired, it'll just return it straight back, but if it has expired, it'll then go and refresh it. So what it does to refresh, what I've done here, I've just done this conditional. First I check for whether it's got an expires at key in the API key, and you can see I've put one in, 1755083607, which is the number of seconds since the 1st of January 1970 in UTC time. And that's fortunately also the timestamp that Python uses for its datetime library. So I can compare that time to the timestamp, and if it's either I don't have one or it's before that the current timestamp, then I'll print up the token's expired, and I'll go off looking for a new access token. And so I've got the URL here that I need to go to get the new access token. I have a payload that I need to pass to it. And to find out how to do this, I've got a reference here in authentication. So you can go there and read the section on refreshing expired access tokens. So I have to give it the client ID, I have to tell it the secret, and I say I want it to refresh my token, and I have to send it the refresh token, not the access token. And I'll give it the refresh token, and it'll come back with a data. So we're going to send what's called a post request. And post, this is an important part about using the REST API, is whether you're sending GET requests or post requests. A GET request is like clicking on a link in a web page, and a post request is like clicking on a submit button in a web page. So we're like submitting a form with this payload, which is the data that was on the form, sending it to that URL that we've defined up there, and it'll come back and with a response. If it's okay, then I can get the new tokens out of the response. I'll store them in the dictionary, and I'll do a partial reveal so that we can have a look, see what it's got, and it should just have a new expires at value. And then I'm going to store it back into the same file. So next time I come along, if it hasn't expired, which will be, they expire every 6 hours, so very likely it will have expired, but if it hasn't, it can just keep running my code. All right, so let's run this cell. So it defines the function, and then the next cell is going to run it. So remember, API key has got my API key out of the file, and then I'm just going to pass it in as a parameter to refresh key and store the result back in API key. So let's do that and see. Fortunately, the refresh key function has told us that it was expired, and so it's refreshed successfully. So it's gone to Strava. It's got a new key that expires at a later date and time. So there's the new date and time, and it's saved the new data into my Strava key.json file. So that'll be useful next time I need it. And so really the good thing to do is every time you're about to use your API key, just check if it's expired. And you can just do that by this one line, API key equals refreshed key API. So let me know if you were successful in getting a refreshed key, and that'll be good. Okay, so once we've got our key, that's really, I think that's the hard part. The rest is going to be pretty easy. So we want to get some details about the athlete who's got this key. So what we're going to do, we're going to use the requests, and this time we're going to use a GET. So remember I said GET is like clicking on a link in a web page, post is like clicking on a submit button. So we're going to use a GET request. We're going to go to that URL, and if you want to know what these URLs are, I've got the link here for getting started. So let's go and have a look at that, and we'll do it in the other where I'm logged in. Yep. So this tells you all the things that you can do with the API, rate limits, uploading files, how to create an account. There's my API application, so we've done all that, and how to make a request. And so they're using the command line, so they're going to be using the curl library or the curl command on the command line to do it. But we are using Python because that's what this is all about. And then it talks about how to authenticate, so we'll get onto that later. I think there was something, oh yeah, how to use the Swagger playground. So this is all also useful. So to go to that, you can go to this link and it'll take you to Swagger, and Swagger is like they give you all the ways, all the commands that you can do, so you can look through them. So you have to authorize, and we'll go through authorization soon. But we're going to be, what are we going to be doing? I think we're going to be looking at an activity. Oh no, we're going to be looking at an athlete. So we're going to get the data for an athlete. And you see here it tells the different sorts of things that you can do, either a get request or a put request. So the put you could actually use to update an athlete's data, or a get request if you want to see existing data. And if I click on that, it'll give me some examples of the data that we're likely to get. It tells me what parameters I need to send through, which is none. It tells me the content type, which is JSON. And sometimes if an error happens, it'll tell me what an error is going to look like. All right, so let's go back, and we've got that information. We're going to, oh yeah, the other thing here, it'll tell us somewhere there's a base URI. Oh yeah, right, base URL right up here is www.strava.com/API/v3. So it's that URL /v3 then /athlete is what we need. So here we are, we've got that URL, https www.strava.com/API/v3, and then we put athlete on the end. And by looking up this getting started, it would have told us that we need a header in our request. So this is like an HTTP header, which you don't normally see, but the web browser takes care of this normally for you. But because we don't have a web browser, we're doing this from Python, we have to provide a authorization header. And we're saying it's an authorization, the header is called authorization, and the content is bearer and then our access token. So I've just used an F string there to set that up. And then when we do the get request, it just provided the URL and the headers, and it will get the response. We say, all right, we want to convert the response to JSON, and the request library does that for us automatically because it's such a common thing that people need. So we've now got API owner data in it's either a dictionary or a list. JSON works that out. And then I'm used the pretty print library to print it out. So if we run that, now this is my information. So if you've done it using your Strava account, you should be able to get see your information here. So you can see when I've created this Strava account back in 2019, and some things about me, where I live and how heavy I am, all those sorts of things. All right, now if that's all the information we can get without authenticating, I mean, there's been a little bit of authentication going there because we've passed it an access token, and we could only do that by having logged into Strava and getting that access token. But now we want to get more information about this person, and we might want to get information about someone who's not the programmer of it. So in that case, yeah, the person who's using your program needs to be able to authenticate with Strava in a way that you don't see what their password is, and but then you can get information about them. as being the programmer or the program that's running and trying to collect this information. So if you had a web application, there's ways of doing that. We haven't got to that stage yet, so we're going to pretend we're a web application, and what we're going to do is construct a URL, which is going to be similar to what a link would look like on our web page, and then it's going to go to Strava, and then Strava's going to authenticate you by logging you in, and then it's going to try to come back and call your web application and give it a callback function. So we're going to say our application is running at localhost, so that's our redirect URI, and localhost is just your computer. We want to have this scope. We want to be able to read data about the athlete, and we want to read data about the activities of that athlete. So that's what the scope is, and when they get asked to authorize, they'll be asked to approve that we can look at that data. And if you go back to Swagger, I think that might tell you what scopes you need. Tokens with read all scope will receive detailed athlete representation. All others receive a summary. Okay, so we've got read scope, so we just get the summary. And this time we're going to be looking at activities. And for activities, we need this scope here, activity read all. Here we go. We need activity read for everyone and the followers' activities. If we just want to read public activities, but if it's a private activity, then we'll need this activity read all. And so the Strava account owner will have to think carefully if they want to allow that information to be given to you. Okay, we'll go back to our Colab, and so what we're doing is we're going to construct a URL. It's going to use this structure, and if you go to the authorize section that I linked to before, you'll see where this came from. And we're going to pass in the parameters. Now, because it's not Python that's doing this call, it's the user in their web page that's clicking on this link. We have to construct it manually. So we're just going to use the URL lib to construct this URL. It's not going to call the URL, it's just going to construct it and then print it here. So let's run this. And it says open this URL to authorize. And it's created a URL, and Google Colab's recognized it as a URL, so it's actually made it a link. So I'm just going to right click on that and say copy the link address. Because I need to run it in a Google Chrome web page that is linked to my Strava account. So we'll go over here to one where I'm logged in as me, and we'll paste this link. And so we're now on Strava. Strava thinks that we've come to it from clicking on a link on a web page. We can see it's got the name that we created when we created our API key, and it's saying we want to be able to view data about your activity. So that was the scope activity:read, and view data about your public profile. So that was the read one, and everyone has to tick that. They can't untick it if they don't want. So they could effectively untick it, and then the rest of our stuff wouldn't work so well. But assuming they tick it, they click on authorize, and then we get this error message because it's trying to call back to our web application, which of course doesn't exist. But what we can do is we can look in the address bar and we can see the URL it was trying to call back with, and the important thing is this code. So if you can copy that code, and don't try to copy my code because it's very long and it can only work once. So if I run it and I find it doesn't work, then I can see someone's actually copied it, and I'll just have to create a new one. But we're going to take it back to our Google Colab, and it tells you here which part of the URL we're trying to escape. So I've got another example code here, and we want to extract the code there. So we run that, and this cell is using the input function, and the input creates this box down here that I can paste the code into and press enter, and it works. All right, so obviously no one managed to get to my code before me. If you tried it now, it won't work, but I've put it in. It's given me a new token, and it's I've asked it to save it in a file called Strava token.json. So that's this one here, Strava token.json. And now this one it's pretty similar to Strava key, but I'm going to use that for all my requests now, because it gives you a lot more scope. Rather than just seeing one athlete's summary data, I can start looking at activities and other things about that athlete that is what I need. Okay, and you can see that the contents of it is slightly different, and even refreshing it is slightly different. So I've created another function here, refresh token, as opposed to refresh key, and it looks very similar, but to refresh it, it takes some information from my key, like the client ID and the secret, and it takes some information from the expired token, such as the refresh token ID, and puts them together and sends that off to this URL where it's asked to refresh the token, and it will come up with a new one if it's expired and store it once again into the file Strava token. So that should and then you just call this function every time you're doing a request on the API, just before you do it, and so it'll be ensure that you have a nice fresh token. So I defined that, I ran it, okay, and I haven't run it actually, I've just defined it. Use the Swagger playground to explore the API, which we've already been and had a look at that. All right, we'll look at this one here, athlete activities. Yeah, let's go there. So I'll close that. Which one am I looking at? Athlete activities. Okay. Clubs, routes, streams. Oh, here we go. Athlete activities. List the athlete's activities. So this is saying to run this, we need activity read, and which we've asked for, so that's good. And that's for the public ones, so we're only interested in public ones. We've got to provide this. We want activities that are before a particular timestamp, after a different timestamp, and we can also page the results if there's a lot of them. So that defaults to just the first page, and it defaults to 30 at a time. So it just means if someone's done thousands of activities and we ask for all their activities, we don't get bombarded with the thousands of data rows when we're really just interested in a couple. So we're going to, that just shows the response. Okay, so that's what we're going to do. Remember that, and we'll go back to our Google Colab. Remember here, we've got before, which is a JavaScript epoch timestamp, after, a page, and per page. So they're the 4 pieces of information we need to pass to it using our get requests for all the activities for a particular athlete. So I'm going to I want all activities between the 15th of December 2024 and the 1st of February 2025. So I just use the date time library to construct those times by passing in the time zone that I'm interested in. It means that this timestamp will actually convert it back to UTC before it tells me the timestamp, because that's what I need. It's Strava is going to be using a UTC timestamp. Okay, so let's have a look. I just ran that, and it just tells me that's the integer for my after date, and that's the timestamp for my before. So the after's got to be before the foot before, and so it's I'm going to get all the activities between those two dates, so the 15th of December to the 1st of February. Okay, so I'm going to use my activity token, and remember, I'm going to call my refresh token function before I use it. And refresh token requires both the API key and the old activity token to see if it needs refreshing. Then it's going to call that URL, which we saw from Swagger. It's going to use authorization, and this time the authorization is going to use the access token from activity token rather than the access token from API key. So a slight difference there. Then I can define what parameters I need. So I'm not going to do the page and per page. I'm just going to accept the defaults, which is 1 and 30. But I'm going to provide the before and after in so that's a dictionary, and I pass that into my get call using the requests library. So we've got the URL, all the headers I need, and all the parameters I need. And just so these params and headers are the names of the attributes required, or the parameters required in that function, and I've just called my variables the same name, so it's easy to see if I've got to put them in the right place or not. It's going to check if it's right. Activity data is going to come in as JSON and get converted to a dictionary or a list, and then I'm going to print it out, and if there's an error, I'll print out what the response code was. So 200 is an okay response code, 404 is a bad response code. That's like not found. So let's run that. Took a bit longer because there's a bit more data to collect, as you can see. So I'm just going to scroll up. There's a scroll bar. There's quite a bit of data collected. So I got nothing about the token needing to be refreshed, which was probably correct because it's been less than 6 hours than when I created the token in the first place. And then I've got all this data about each of the activities that I've done. There's quite a lot of data there. The ones that we're going to be interested in are name, distance. There's distance in meters, and probably the date. I think we've got a start date. Here we go, start date. So they're the ones that we'll be interested in. And later on, it's got a map, which has got this polyline thing in it. So that's one of the things that we'll be using. All right, so let's. That data was all in a list. Actually, we'll just have a look to see that was a list. Yeah, it starts with a square bracket there, so it's all in a list with all these dictionaries, and it's a list of dictionaries that it's converted the JSON into. So we can do a for loop through that. I'll just take rid of that for now, and we'll look at the start time and print the start time, the distance, and the name. Okay, so the start time, I parsed the data that they provided, which was in that format, and then I've converted it to my local time zone, so as time zone Australia, Brisbane. And so that's saying that at 7 minutes past 5 in the morning of the 30th of January, I did a 7.7 kilometre run called Church to Ville. Okay, now unfortunately that's put all the data with the most recent first, and say I wanted it in chronological order, I could just reverse the list by putting in this slicing, or list slicing, and the -1 says go backwards. So there we go, now it's in chronological order. So you can see it started on the 28th of December. Obviously I didn't do any between the 15th and the 28th, none that I recorded in Strava. And I can see what runs I've done. All right, now we want to try plotting this data, and we want to plot it onto a map. And so to do that, we need a couple of additional libraries. Folium actually comes with Google Colab, but Polyline doesn't. In fact, you can see down here, Folium hasn't got the squiggle underline, but Polyline does, saying it could not be resolved. So we want to install Polyline. I'll leave Folium there for now just to show what happens. Now this is not a Python command. This is a line I want to run on the command line in the bash shell that's underlying our Python here on our Google virtual private server. So I put an exclamation mark at the beginning. This is just a feature of Jupyter Notebooks, that it'll drop down to the shell and run this command in the shell. So let's run that. And so it's seen that I want to install Polyline. So it's gone to pippy.org and found Polyline. Then it's gone to install Folium, and it's gone, actually I've already got Folium, it's already installed, so I'm not going to do anything about it. And then it's looked at what dependencies of Polyline and Folium need to be installed, and so it's checked all of them and said actually you've got all of them. So all it needed to do was install the Polyline package, and it's installed version 2.0.3. So now when I look down here, it can recognize Polyline because it's now installed on that server, and we can run it. So activity data is a list of activity dictionaries that we retrieved from Strava API. So I've just put a bit of checking in here. I think I actually wrote some of this using AI, so it's gone and put in some extra checking. If the activity data exists, then loop through it and see if there's a name that starts with the word Australia, and that's what we look up here. We'll see there was one here on Australia Day, the 26th of January. I did a run called Australia 25. Okay, then we'll get the activity, which is activity data. Remember, is a list of dictionaries. So activity will be a dictionary. If the activity with the key name is the one with Australia, then I want to get the map from it. And remember, map was a dictionary. So I could have used square brackets map, but I've used get just to be a bit safer. And it returns, if map doesn't exist, I'll just get an empty dictionary. And then from then I'll use get to get the summary Polyline from that dictionary. And if that actually exists, then I'm going to decode it using our Polyline library that we've just installed into a series of coordinates. And then I'm going to center the map on the first coordinate pair. So the location here is just the 0th item in decoded coords. So that's going to be where my map is centered, and I'm going to start at level 16. Then I'm going to add the polyline, so folium.polyline, decode coordinates in a blue color with that much weight and that much opacity, and I'm going to add that to our map that we created here, and then I'm going to display it. Now display is a thing specific to specific to Jupyter Notebooks. So as one of the other advantages of Jupyter Notebooks, you can run this display thing, and it does it displays the map. It displays things in a web environment for you. Otherwise, a couple of error messages here. It couldn't decode, or it couldn't find the polyline, or it couldn't find the data. So let's run that and see what we get. This is actually a lot of that was created by AI, and it's drawn the map for us, but the map is not centered on the page. It's just centered where we started, which we started about here. If I drag it up, so it's really nice. I can drag it up. You can see the rest of the course that I did, but it wasn't centered very well. So I might zoom out a bit too. There we go. All right, so what do we want to do? We want to center it not on the first coordinate, but let's find the maximum and minimum latitude and longitude, and then find the midpoint of the course that we've run, and then we can center on that point instead. Okay, and we're probably going to want to do this quite often, so let's do it in a function, and then we can just call the function with different names that we want to use. So I've created a function here called plot activity, and it's really just the same as what we've done before, except that it gets all the coordinates, and then it finds the maximum latitude, maximum longitude, and minimum longitude using these built-in functions, max, and the list of tuples that we've got. You can see there what the structure looks like. It's a list with tuples in it, and then we say the key is, and we've used a lambda function here, which is just a one-line function rather than defining it somewhere else. Provided x, I just want to look at x0, so provided a tuple, I just want to find the first element in that tuple and find the maximum of all those. So that'll find me the coordinate with the maximum latitude, and then from there I just want the latitude of that coordinate with the maximum latitude, so that's the last square brackets. Then my map center is just going to be that's halfway between the max and minimum latitudes and halfway between the max and minimum longitudes. Alright, all the rest of the code's the same, and then I can just run this plot activity, pass in my list of activities, and look for the one that starts with Face of St. Lucia. Plot activity is not defined yet. So we looked through it, but we didn't run it, so it's not defined. So let's run it, and then we can run this one. There we go, nicely centered on the course, not where we started. We started over here, which is now off to the one side. And you can see the run that I've done, and I've created a face in Strava art, wearing a cap, and that's just around the University of Queensland here. So that was a lot of fun. Alright, so that's the end of what we've been doing. You can see that's plotted in OpenStreetMap, so that's good. It's using the leaflet JSON stuff, JavaScript stuff. If you do create a web application that stores data retrieved from this API, then one of the important things in the terms and conditions that you will undoubtedly read in detail when you're signing up is that you need to respond to webhooks. And the reason you need to do that is because if you're storing someone else's data and then they decide that they don't want you storing that data, they need to be able to go to Strava and say, get rid of my data, and then Strava needs to be able to go to your web app and say delete the data for that user, and they'll do that using a webhook. So you need to be listening should Strava ever request a particular person's data to be deleted from your database. It's only if you're storing the data. If you're just using the data and not storing it, then you don't have to worry, because you are effectively deleting it every time you finish using it. All right, well, I hope you learned something. I didn't get many questions for that. I'd be interested to know if anyone successfully managed to plot any charts of their, or maps from any Strava activities of their own. But I think it's something that you could have a lot of fun with, and I certainly enjoy going out for a run and trying to do this Strava art. It's always a surprise when I look at it later whether it's just which bits look good and which bits don't look quite so good. And that's it for me for this week. Yeah, and my next session will be first week of September on Wednesday, and it'll be aimed at absolute beginners, so not quite as advanced as this sort of session, just really getting into the absolute basics of Python. So until then. Oh, here we go. We've got Joran said, managed to plot a couple of my runs, learned a lot. So that's good to know. Okay. Yep. Thanks, Chris. And we also got Leo has responded on Strava, so he's been watching it from there.